Number 10, give me the problem. Analysis, yes? Yes. Let me graph it. Oh. Come on. Oh my gosh, y'all will come up with everything. Y'all stop. Y'all come up with the craziest rules I've ever heard in my life. They are? Y equals, tell me, Madison, tell me one more time, what was it? X to the third? I'm going to do Zoom 6 and see if I can see everything I need to see. I cannot. So I need to zoom out. I'm going to take my window out some more. Let's go negative 50 to 50. Oh, maybe I could see it all. This was a cubic? Oh, yeah. Oh my God. That's not what all right, so it looks like, what do we have? Domain. Negative infinity to infinity. Range, okay, so this number 10. Negative infinity to infinity. Range is negative infinity to infinity. What did it ask next? So I'm going to have to go in my calculator and find this. So second trace, minimum, that is a relative. There's my spider. Left, right, guess. Relative minimum looks like negative 2, 1. Maximum, negative 4, 5. So negative 2, 1, negative 4, 5. This is the relative min. This is the relative max. What else did it ask you to find? All right, so this point, I'm going to write these points on here so I can tell. This is negative 2, 1. So increasing, go by the x. Go by the x. So negative infinity to negative 4. That's right. How about decreasing? Negative 4 to negative 2. What's the minimum? No, that doesn't work. Okay, what's the next thing I have to find? What is it? In behavior. As x approaches infinity, f of x, there you go. As x approaches negative infinity. What else? Pretty easy, right? Give me the equation. So I'm assuming it's this little hump that's throwing you. I would go decreasing here until I get to this minimum. When you get here, this is increasing, 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 increase. It's always increasing from here on. There's no minimum there or no maximum. It never really dips around. It just keeps going up just ever so slightly up. Give me the equation. So I need to go for range negative infinity up to, and I need to calculate this to find that y value. $2.4. Anything else? I don't know. What number was that, Sullivan? 11. Right. All right, that's how we do it. If I didn't have a calculator, this is zeros and multiplicity. If I did not have a calculator and I asked you to find the zeros of this function, can we wait? Yes, right. I'm gonna give the girls that make their notes pretty just a minute. Watching them make their notes all pretty. They do it in like a colored marker, and then they have a colored pen, the same, like a different shade. No, it doesn't. They look good. I probably could. Let me see. I'm the original. What are you talking about? She has to be like me, not the other way around. I'm just kidding. No, I was doing mine like theirs. Copy Caitlin on hers. All right. No, I'm not creative and artsy like that at all. We said we'd find the zeros. Yes, we said we'd solve it for x. We'd make it equal 0. Well, then what do you do? How do you do that? Oh my goodness. Yes, Corey. Take out an x. That's exactly right. What's left? Now what? Now I can say what multiplies to negative 10 but adds to 3. What is it? 5 and negative 2. So these are the factors, yes? And what are the zeros? Degree was 3. I needed to have at least 3, and I do. So the difference now in what we did last year and what we're going to do this year is our factoring is going to kind of, or our solving and our factoring is going to kind of get a little more difficult. Nothing that you haven't done. Let's see. How are you going to find those zeros? It's not a quadratic anymore. Not everybody at once. Can't use quadratic formula because it's not a quadratic. There you go. Say it again, Anna. Say it again. You can still factor it like normal because I can't hear what you're saying about adding this and adding. Oh, what'd you say? Yes. Sorry. Yes. Yes. So what you're doing is factoring like normal because if this is even and this is half of that and this is a constant. Oh, I hate that little thing. Hate what? I'm sorry. If that happens, if this is even, this second exponent is half of the first and then there's a constant at the back, I can factor it like normal. So what multiplies to 36x to the fourth but adds to negative 37x squared? Negative 36 and negative 1, right? And so I fill this in, 9x to the fourth minus 36x squared minus x squared plus 4. I'm ready to slash. What can I take out of the first two? X squared. What's left? Middle sign stays. Can't take anything out of the second two. So now I have 9x squared minus 1, x squared minus 4. When the middle sign's minus, are you talking about the sign here? Hold on a second. When this, oh, yes, you can. We're fixing to do that. You're talking about 3x minus 1, 3x plus 1, x minus 2, x plus 2. Yes, you can, in order to get it fully factored. What were you saying? Why? Is that what you were saying too? Huh? Yes. Well, if it asks you to fully factor, you do. If it just asks you for the zeros, you could technically solve this for x without doing that. Yes, Lee. What? No, what? Yeah. This is exactly why we don't learn. All right. Multiplicity. So here's what happens. Multiplicity is the number of times a solution happens. Okay, so if I get something completely factored down, that door keeps opening and closing, and there's nobody walking by. Something like number of times what? The number of times the solution repeats. In other words, looking at something like this solution, what's that solution there, by the way, or what's that 0? 1. And it has a multiplicity of 2, sorry. Whereas this solution is what? -5, and what does it have a multiplicity of? 3. Does everybody see where multiplicity is coming from? I'll give you a second to copy it too. So it's how many times it happens, right? And maybe even if I had a x to the 10th here, yes. This is 0 with multiplicity of 10. Okay. I was just showing you don't have to. I was just showing you. So here's why this is important, and this is all I'm going to do today, and then I'm going to stop here and let you. I'll do an example, and then I'll stop and let you work since we had a quiz and all today, and it's getting late. What does this tell us? If the multiplicity is multiplicity is even, what does the graph do? Bounces. If the multiplicity is odd, it goes through. Do y'all remember this? Bring him right back. All right, so you may get it in factored form like this, or you may have to manipulate it to get it into factored form. So let me show you an example, and then I will be quiet. Y'all got this? Identify all the zeros, their multiplicity, and the effect that the multiplicity has on the graph. Mark, set, go. Slade, you are distracting people. You're distracting people. I'm going to start the homework sheet going around. They're all factor stuff. Oh, oh come on. How do you factor this? Take out x to the third. What's left? Can you factor it further? Yes, it is. This one's squared answers. So x to the third, nice job, Delaney. Square root of this times the square root of that is 4x, doubled is 8x, so it factors as x plus 4 squared. If you did not remember the PST and you factored it out like normal, that's fine too. You could also shortcut this one since there's no leading coefficient in the front. Okay, so I asked you for zeros, their multiplicity, and the effect that it has on the graph. So give me one of the zeros. Is -4. What's its multiplicity? 2. And it bounces at 4. So remember, whatever else is going on at -4, this graph is just whoop, touching and then bouncing off, right? That's what we mean by bounces. Any other zeros here? 0. X equals 0. What's the multiplicity? 3. What happens there? It goes through. All